Alright, today we're going to be looking at dividing a polynomial by a monomial. We've already spent one class dividing monomials, or a monomial by a monomial. Today we're going to be actually taking something that's multi-terms and dividing it by a monomial. If you look at the sample problem we have here, this example, we have 4 terms divided by 1 term. Well, to do this problem, you just have to break it down into mini problems. So we're going to take each term that's in the numerator and divide it by that denominator. So we're just going to rewrite it as 4 separate mini problems and then do each little division problem. So looking at that first problem, 10 divided by 2 is 5. X to the 5th over x to the 1st is more x's on top, and how many more? 4. Plus 6 divided by 2 is 3. More x's on top, and how many more? There's 2 more, because 3 minus 1 is 2. Minus more x's on top, and how many more? 1 more, but we still have a 2 on the bottom because it didn't have anything to simplify with. And then plus our x's, we have 1 on top, 1 on the bottom, so they cancel out, and then 2 divided by 2 is 1. So that would be our answer. So that's how we handle dividing a polynomial by a monomial. We just break it down. So looking at this first example, I take each top term and divide it by the bottom, plus 4n to the 3rd divided by 4n squared, plus 8n squared divided by 4n squared. So just took each one of those, made it into a mini problem. Negative 4 divided by 4 is a negative 1. More n's on top, and how many more? 2. And then there's nothing but a 1 on the bottom, so I don't have to write that. Plus 4 divided by 4 is 1. More n's on top, and how many more? 1. Plus 8 divided by 4 is 2. And my n's will cancel because there's 2 on top and 2 on the bottom. I could clean this up a little bit, write it as negative n squared plus n plus 2. But either one of those answers would be acceptable if you left the 1's in there or not. Just know if this was a multiple choice test, the answer with the 1's would not be there. All right, example 2. Same thing, break it down. I'm going to have 3 separate problems. How do I know I'm going to have 3 separate problems? Because I have 3 terms on the top. And I like to make sure and go and put the 1's on my variables that don't have exponents. So 5/4 doesn't reduce, so it stays as 5/4. More x's on the top, and how many more? 2. Plus 3/4 doesn't simplify, so 3/4. More x's on top. How many more? 1. Minus, my x's are going to cancel here. 1 on top, 1 on the bottom, so they all cancel. And 4 divided by 4 is 1. Now, it's possible to write this slightly different, or if this was a multiple choice test, it would just show the 5/4 x squared, because a 5/4 is a coefficient of x squared, plus 3/4 x minus 1. And I can do that when the variable is on top, not when it's on the bottom. All right, number 3, written a little bit differently, but it's the same thing. I'm still taking what's in the parentheses and dividing it by the denominator. And then I want to write it into separate little problems. That would be my next step. And I just need to simplify it. 18 divided by 6 is 3. More b's on top. How many more? 1 more. Plus 3 over 6 reduces to 1/2, and my b's cancel. Plus 18 divided by 6 is 3. There's more b's on the bottom, so my b's have to be on the bottom. And how many more? 1. that would be my answer. Now again, if it was multiple choice, these b's in this problem would not have the 1s on them. And then the example 4, we have 24x squared y squared divided by negative 6x squared y squared plus, because we have a minus divided by a minus, so it's going to be a plus 16x squared y to the first divided by 6x squared y squared. And some of you might say, isn't that negative 6? But remember, I took care of that already because I said a negative divided by a negative is going to be a plus. Same thing on this third one. A negative divided by a negative is going to be a plus 12x to the first y to the third over 6x squared y squared. Then I have to simplify. 24 divided by a negative 6 is a negative 4. The x's cancel because there's 2 on top, 2 on the bottom. Same with the y's, 2 on top, 2 on the bottom. So that's just negative 4. Plus 16 over 6 can be reduced by 2. So that would be 8/3. X's cancel. More y's on the bottom, and how many more? 1. Plus 12 divided by 6 is 2. More x's on the bottom. 1 more on the bottom. And more y's on the top. 1 more on the top. And then if I could just clean it up by not having the 1s. Remember, if the variable's on the bottom, I can't rewrite it like I did on the example above on example 2. Because you can only do that if the variable's on the top. And that would be my answer. On the back. So one more example. So example 5 is what you would call a word problem. The area of a rectangle is shown. So the area, the length times the width is this right here. 20x to the third plus 4x squared plus 8x. That's what the inside is. We know the width is 4x, and we're missing this measurement. So when we think about finding the area of a rectangle, we find the area, we do length times width. But what if we know the area, and we know the width, and we need to find the length? Well, this goes back to what we did in Unit 3, solving for a different variable. So I'm going to divide this by W. So my length is equal to my area divided by W. And that's what I'm going to do with this problem. I'm going to take my area, 20x to the third, plus 4x squared, plus 8x, and I'm going to divide it by my width, which is 4x. And I'm going to break it down into the mini problems, like we did on the front. And then simplify each one. 20 divided by 4 is 5. More x's on top, and how many more? 2. Plus 4 divided by 4 is 1. More x's on top. How many more? 1. Plus 8 divided by 4 is 2. And my variables will cancel there because there's 1 on top and 1 on the bottom. And there's my answer for the length. And I could take that length, times it by 4x, and I should get that area. That's the way I can always double check that. All right, now you go ahead and work on the you-dos. See how you do.